Good morning and welcome to the Boston Plastic Recycling webinar series. In this chapter, we're going to tackle the assurance of the quality recycling with the tool PRE-1000. So today's agenda will start with the explanation of the objective of this webinar and the PRIMUS explanation. Afterwards, Mathilde will deep dive into the legislation context of the current recycling industry. Afterwards, Jarko will explain the sampling study that he has created in the PRIMUS project for the plastic waste. Afterwards, Mathilde will introduce the tool PRE-1000, and at the end of the session, we will have the industrial testimonial for the from the Coolrec company that will be led by Ana Rita. At the end of the session, we will have some roundtables with some questions for all of the presenters. And if you have any question, please write it down in the chat and we will let them know and answer them at the end of the session. So the Boston Plastic series is under the umbrella of the PRIMUS Project, and we created this webinar series to focus on unraveling the latest updates and good practices of the plastic recycling, and as well as sharing the result of the PRIMUS Project. So this webinar today is dedicated to enhancing plastic recycling quality by implementing the industrial standard of PRE-1000. So this session is part of the PRIMUS project and will provide valuable insights into how recyclates can meet the highest quality standards. So let me present myself. I'm Carolina Mejia, Senior Innovation Project Manager at Mondragon Corporation, and I'm the Communication Dissemination and Exploitation Leader from the PRIMUS project. I have experience in circular economy, Industry 4.0, and Smart Cities R&D projects, and I have a architectural degree with 3 masters in urbanism, innovation, and project management. I'm working as a senior innovation project manager at Mondragon Corporation for the past 8 years, boosting the R&D technologies for more than 260 companies, as well as leading Mondragon's environmental forum. So for my side, I will present a little bit of the PRIMUS project in a glance. So the PRIMUS project is a European project that will improve the plastic recycling industry with new polymer recycling technologies for automotive and home appliances applications. So we have 4 demo cases, 2 for automotive applications and 2 for home appliances. And we are 12 partners located around Europe, as you can see on the screen. We started this project on May 2022, and we have a duration of 3 years. So right now we almost are finishing our dearest project. We just have 6 months ahead, and we have a almost 7 million euros budget, and we are targeting technologies from TRL 3 to TRL 6. So PRIMUS at a glance, the main objective is to increase the sustainable use and production of quality, safe, and circular plastic recyclates for added value products, focusing on the traceability to increase the transparency of the plastic value chain. So first, we create those recyclate safe plastics from recycled plastic with technological innovation. We support all this value chain with safe traceability. We demonstrate the traceability, the technologies, and the plastic recycled plastic in the 4 demo cases, 2 on automotive and 2 on home appliances, and we support recyclates market with advanced mechanical recycling, debromination, pretreatments, and analytics. So, taking a glance on the 4 demo cases that we have on the project, the first one is related to automotive interior, where we are upgrading recycled PC, mix it up with ABS to create an automotive interior with an injection molding technology. The second pilot is the automotive cooling circuit that we are upgrading recycled PP and EPDM to react together, creating a TPV and create the cooling circuit. The third pilot is a refrigerator to refrigerator, where we have a food contact demonstration where we are gathering refrigerator liners and recycling the plastic that it hips to create new refrigerator liners with all the food contact tests and migration tests. And for the fourth pilot is the washing machine door sills that we are gathering as well, different machine door sills to recycling them and the plastic that in this case is EPDM to produce new technical washing machine door sills. So if you want to know a little bit more about our project, you can join our industrial stakeholder group. You can scan the QR code and you will have access to all the publications and different questions and webinars and posters and policy brief that we are creating. So now I will present Mathilde Thomas. She's a regulatory affairs manager at Plastic Recycling Europe. Welcome, Mathilde, and thank you for being here. She is the PRIMUS regulatory work package leader. She holds a master in chemical engineering, specialized in materials and processes. Her graduation research on the development of PP recyclates from old household appliances led her to the plastic recycling world. After working as a plastic engineering at a recycling facility, she is now focused on the chemical legislation as well as on R&D projects at Plastic Recycled Europe. Welcome, Mathilde. She will be presenting the legislation context, and please, Mathilde, the floor is yours, and please take the control of the presentation.
Thank you very much, Carolina, for the introduction, and welcome everyone on my behalf. To start this webinar, I will explain a little bit related to the legislation context that is surrounding everything that has to do with legacy substances. So first of all, I will explain you on the legal obligation that are surrounding the recyclates on the product legislation side. So you know there is two types of legislation. There is the waste legislation and the product legislation. And here, because we are placed on the output fraction of the recycling plastic, then we will have a look at the product legislation and therefore the chemical legislation. Indeed, the recyclates, if they are placed on the market as a product, then they have to comply with the product legislation. So here we have a couple of legislation that are mentioned. The first one is the SVHC. So this is the substances of very high concern. Here, for those substances, they can be present in the recyclates, but if they are present above 0.1%, then there is an obligation of reporting those substances to the customer that is next in the value chain. Then we have specific substances that are restricted under REACH. This means that it's a restriction where there is potential derogation for specific sector, but it means that if the substance is present above a certain threshold in the recyclates, then those ones cannot be placed on the market as a product. Then we have, I will go for the last one, the persistent organic pollutants. So this is a specific legislation that has both a part in the waste and in the product. The part of the waste is related to the Annex 4, and the part of the product is the Annex 1. And here for the Annex 1, it means that if there is a specific threshold for different substances, if this threshold is exceeded, then the material cannot be placed on the market. And then there is a last one that is more sector specific, is the restriction of hazardous substances, the ROS. And in this one, it's especially applicable for electronic and electrical equipment. It means that it's only restricting certain substances if the recyclates is placed back in this type of application. So you see that there is only one legislation here that covers both the waste and the product, but this is in different annexes. In between, the line that you have between the yellow and the green is, of course, the end of waste status that needs to be reached in order to go to the product category. And to go to the product category, you have to prove that you comply with the product legislation. Then we go on to this end of waste criteria, and especially the criteria D that we will see. So the end of waste criteria is defined in the Waste Framework Directive. It defines generic criteria that will be specified in the future, especially for plastics. But at the moment, we are still stuck with the general criteria of the end of waste the Waste Framework Directive, sorry. And so you have different points. The first one is that the material needs to be used for a specific purpose. The second one is that you have to prove that there is a demand or a market for this specific material. The last one, you have to prove that there is that this material meets the technical criteria that are recommended for the application to be able to place it on the market. And the last criteria that is relevant for us today is that the use of the substance or object, so therefore the material, will not lead to overall adverse environmental or health or human health impacts. And this is technically linked to the compliance with the product legislation because the threshold have been set in order to protect the human health and the environment. So if those ones are met, then we can conclude that if we place this specific recyclates on the market, then it will not lead to overall adverse environmental or human health impact. Of course, taking also into consideration the sector-specific product legislation. If the material goes to food contact, then of course you have specific human health criteria to check on top of the one that we mentioned before. Now, another part that will pile up based on the two different criteria that I explained before is also the customer request, because some customer will have their own substance specific list that will have to be checked. So if we take into consideration all the criteria that we mentioned before, so there is the legislation, there is also the point of the end of waste, and then there is on top of this sometimes some customer requests. So it means that the recyclers have to comply with a very wide number of thresholds that are requested for the article to be placed on the market in a specific application. So if we look at everything that we have seen, so we have the rich SVHC, the restriction of the rich, the POP substances, and the ROS substances. And this is typically all the substances that have been included in our tool, the PRE-1000 method. We have created this method because of all the substances that the recycler have to test. This is a very costly process if you have to test all of them. And therefore, this is why we built this method that we will explain in more detail afterwards on how to test those substances in a systemic manner, in a more monitoring way and easier way than it is to do any analytical technique for every substances that is present in this 4 different legislation. So the concept is as follows for the end user's requirements and the basis of the PRE-1000. So of course, it is very important to monitor the presence of potential substances of concern that can be present in the recyclates. The fact that we are testing and monitoring those substances is also creating trust in the recyclates, and it can also lead to the attainment of higher quality markets. Of course, this specific method and system will be a very good tool in order to provide some effective statements that you can say with high confidence that those substances of concern are not present in the recyclates above a certain threshold. And the system is also based on a good sampling methodology because, of course, in order to have good results, you also need a good sampling methodology. And of course, because we are based on this reduction of substances based on certain parameters, then it's also a cost-effective method. So I will go into more detail into the presentation of the methods and how it works and why it is cost effective. But before this, we will dive deeper into what the good sampling methodology is and the work that we have performed in the PRIMUS project. So I will let the floor to Jarkko.
Okay, I will take control and
Jericho, let me introduce your. Jericho is a professor and scientific excellence manager at the University of Eastern Finland. He's our Primus characterization work package leader. He holds an PhD in physics and in technology, and he has acted as a professor of materials chemistry and engineering at the University of Eastern Finland in Joensuu, Finland, since 2018. He has co-authored more than 80 scientific peer-reviewed articles dealing with nanomaterials characterization and application with more than 20 years of research experience. So now the floor is yours, Jarko. Thank you.
okay, thank you very much, Carolina, for the introduction. And I will give an overview of the sampling protocol that we have been developing within the PRIMUS project. As we know, one of the typical issues in the, especially when it comes to the recycled materials, is to how do we get representative sampling of the materials, and how can we guarantee that the things that we are actually measuring are actually the ones that are present in the streams as well. So in order to make this, realize this representative sampling, this is the basic concept that we have been developing within the project. So there are 4 scenarios. So what we do have as a starting materials is that we have virgin high-impact polystyrene flakes. We selected 98% of these virgin flakes, and then the 2% of the material is contaminated either by using a blue-colored colorant for the means of visual inspection of the samples. And then in order to do more quantified analysis, we also added 2% flakes with a known concentration of the brominated flame retardant, which we can then quantify using either X-ray fluorescence spectroscopy or then mass spectrometry characterization and quantification. The 4 scenarios, so what we did was that we mixed these with the known ratios. And then the sampling scenarios was that first we just take the flakes, we do injection molding, do dog bones, and then do analysis. Then also we did as an intermediate step doing extrusion or compounding in between, forming granulates, and then doing the injection molding of the dog bones and doing the analysis. And we also tested what's the effect of the cryogenic grinding of the material. So more or less the scenario number 3 is the same as the scenario number 1, except that we now do the cryogenic grinding of the material. So the flakes have been grinded down to the 500 micrometer scale and then mixed. And then also doing the scenario 4 with the cryogenic grinding being similar to the scenario 2, except that we do the cryogenic grinding before doing the extrusion and then the injection molding. So as a starting point, if you just consider that we have a visual study of the first scenario, we have an input material, we have the white flakes of the high-impact polystyrene, and then we have the colored ones mixed with a small ratio. We just do the injection molding, and on the right-hand side, you can see the output of this approach. What we see, indeed, as one would expect, that it heavily depends on the odds of having blue-colored flakes in the stream as you are doing the dog bones. So then we do see a significant variation in the output stream. So some of the dog bones are more or less intact, whereas then some of the dog bones that have been just injection molded are showing a significant density of the blue color. So we can clearly see that this is not a sufficient manner of doing representative sampling of the streams. So then we have studied the 4 different scenarios. So the same mixing ratios, and here is an example of the image that has been also is included in the original peer-reviewed publication that is currently under review in Waste Management Journal. So, as we have seen in the case of scenario 1, just doing the injection molding is insufficient for guaranteeing an even distribution of the colorant throughout the dog bones. Once we do the compounding step in between, we do see a significant improvement in the evenness of the samples. And the same story also for the cryogenic grinded samples. We see that then the density of the color is more or less even throughout these dog bones by means of the visual inspection. So how do we do the actual quantification and characterization of these materials? We at the University of Eastern Finland have been specializing in the mass spectrometry tools for the past 20-30 years. We have very good infrastructure for these for the mass spectrometry. We have the main device that we use is the timsTOF device, so it's the trapped ion mobility quadruple time of flight mass spectrometry shown here on the top. We have very high resolution ion mobility separation, and it's very good for the targeted analysis and considering the accuracy that is needed in the recycled materials, the high mass resolution and the high mass accuracy of the timsTOF device is sufficient for these materials. In the case that we would need additional accuracy in our analytics, we can also go on to the 12 Tesla unit, which is the Bruker Solarix unit. So it's the Fourier transform ion cyclotron resonance device. And then we see that indeed it has the very ultra high mass resolution, so more than 1 million full width at half maximum accuracy and going down to the 0.001 ppm level. So how do we do the analytics in our device? As mentioned, we use mainly the timsTOF with direct insertion probe for the analytics. So here's the example of the plastic sample preparation. So on the left-hand side, you see a typical glass capillary that is used for doing the analytics. So as we can see, we can do on a very small amount of material, less than typically around 1 milligram is sufficient. So we can either take straight from the plastics, or we can do also use in the center, we have the cryogenic grinding using the Retsch ultracentrifugal mill with sieves so that we can have the 0.5 millimeter sieve for these samples. And then these plastic samples, which are embedded into the glass capillaries, are then put into the direct insertion probe into the timsTOF device, and now we do run these analytics in the atmospheric pressure chemical ionization mode. The typical protocol that we use, which we have developed within the PRIMUS consortium. Here is an example, mass spectrometric spectrum of the high impact polystyrene. Roughly, it takes around 10 minutes to run the analytics. Our sampling rate is 50 hertz per 50 hertz, so we can collect a very large amount of data from our measurements. We use a temperature ramp of 50 centigrades. We run approximately 90 seconds at each step. So we start from 150 centigrades, and then we move on to the 450 centigrades, as shown here on top at the total ion count of the high impact polystyrene sample. This is the total ion count spectrum on top, and then from each of the different segments, we can run the mass spectrum analytics. And for example, here, highlighted by the yellow background, the 450 centigrade emission, we do see that mainly the emissions that we see coming out from the high impact polystyrene is emission of styrene dimers, trimers, etc. And also what we can do, what is the main feature of the mass spectrometric tools is that they're very accurate in the qualitative analysis, but we have also developed these tools so that we can do quantification for selected compounds. So here is an example of the mass spectrometric analysis of the colorants. As discussed, we had two different approaches. The colorants were mainly for the visual inspection, and then the brominated species were the ones which were dedicated for more quantified analysis. However, we also wanted to test whether we can see the colorants that have been used in the visual study. And indeed, we pinpointed out two different pigment components from the blue component, which was used as a colorant. And then indeed, we can see the pigment red component as shown here on the magnified image, very small peak in the spectrum, but still visible in the mass spectrometric analytics, showing first the accuracy of the mass spectrometric tools that we have in use, but also at the same time we can see that since the intensity of these pigment peaks is very weak, they are not suitable for the quantification of these materials. So for that reason, we move on towards the brominated compounds. And here is an example of the visualization of the X-ray fluorescence spectroscopy measurement of the bromine concentration. So scenario 1 on the left-hand side, having just the injection molding, and then scenario 2, which has the compounding step in between the flakes and then the injection molding. So the same story, but now doing in a more quantified manner, which we have seen in the visual study, is that indeed there is a significant variation of the bromine content if we just do the injection molding, simply depending on which are the flakes that happen to be on the stream as we are forming the dog bones. Whereas then once we do the compounding in between, we see that there is a much more even distribution of the brominated species along the dog bones as one would expect. And for these ones, the data interpolation was done using 8 measurement points for each of the specimens. As mentioned, we have also done work towards quantification of the mass spectrometric data, and here is a comparison of the normalized intensity that has been measured using the direct insertion probe mass spectrometric measurements, and then also to the bars that are presenting the XRF data of the bromine content of the TBBBA contaminated samples. So scenario 1, once again, on the left-hand side, scenario 2 on the right-hand side. If you consider the normalized intensity, they are reflecting pretty well the XRF data that has been measured in the bars on the left-hand side. And then also we see that the normalized intensity is very well aligned with the bars on the scenario 2, in which we have the compounding step in between. If you just want to go on for a direct quantified analysis of the bromine contents, then once you have the XRF well calibrated, then you can go on use that one directly to see how large is the bromine fraction of your species. However, the only thing that you can measure from the XRF is the actual bromine content, but you do not get any additional information about what is the actual brominated flame retardant from which the bromine is originating from. However, if you do the deep mass spectrometric analytics, then you also have the possibility to see and to identify the actual brominated flame retardant present, as you can see the different peaks, whether it's TBBBA or if it's HBCD or then DecaPD, for example. So then, for the sampling study, some conclusions that can be derived from these analytics is that indeed we used 4 different sampling scenarios, which were related to the mechanical plastic recycling. Were evaluated with model plastic feed of 98% of the non-contaminated high-impact polystyrene, and then 2% either colored or then brominated species. The main messages to carry home here is that indeed, if you just use the injection molding, making the dog bones, that is an insufficient manner of doing representative analytics of the whole stream. However, and then these variations in the injection molded specimens can lead to significantly inconsistent results that you are measuring. And the samples do not represent the entire batch, but they are more depending on which flakes happen to be within that stream while making the dog bones. However, what we have seen clearly here is that if you do the compounding step, the extrusion step in between the flakes and then the injection molding, we can significantly improve the representativeness of the sampling. In addition, we have also seen that the cryogenic grinding is also a sufficient tool for doing a more representative sample. However, if we consider the limitations of the cryogenic grinding, suitable for the lab scale measurements, but then if you would like to apply it in the industrial scale, then that would not be scalable and then suitable for that one, for that purpose. So as a summary, the developed protocol, once you do first the compounding and then injection molding, is sufficient for having a more representative sampling, and then also it should be applicable to the industrial scale continuous operations. So with this one, I would like to conclude my part, and then Carolina will take the control over the presentation once again. Thank you very much.
Thank you, Darko. Now we will go back to Mathilde, that she will explain the industrial tool PRE-1000.
Thank you very much. So now that we learned more about how the sampling methodology work, we can dive deeper into how the PRE-1000 tool work. So this is the concept of the tool. The idea is to have several steps that are applied in order to reduce step by step the number of substances that will be analyzed via chemical analysis. As I said before, a chemical analysis is an expensive analysis, and the idea of this tool is more to have something on a regular basis as a monitoring method. This is why we have designed this cost-effective method in order to do more measurements but less costly. We have different steps. The first step is the product definition. So which kind of material are we analyzing? Are we analyzing a material that comes from households, that comes from ELV or WEEE? This way we can already frame which type of stream we are targeting. A second point of the product definition is also to have a specific polymer that is targeted. So in the recyclates that you will analyze, you have to specify if it's a PS, if it's an ABS, a PP, a PE, and so on and so forth. Then we have the sampling protocol. So this we have seen just before. The idea is to have a sampling method that will then lead to proper results. This is why it's very important to have a sampling that will have a representative sample in the end. Then we have the sample preparation. This has also been discussed before. And then we go for the analysis. The analysis will first start with a DXRF analysis to know the chemical composition of the material in terms of chemical element concentration. And then with this, we will be able to reduce the number of substances to analyze chemically. And this then is analyzed chemically, but we have targeted substances that we will analyze. And afterwards is the reporting towards either the competent authority, if it's necessary, or towards your customer. So the idea of the PRE-1000 is really to have a specific tool that will try to monitor all the substances in a method that can be applicable at the plastic recycling facilities. So how do we make this tool work? So the tool is an Excel file. This is based on a database of more than 200 substances. Of course, the tool is updated regularly because you know that the substances of very high concern are published every 6 months. It means that every 6 months we may have new substances to add into the tool. There is also other changes in thresholds. So this tool is updated very regularly. The first thing we are doing is a literature review about the specific substance that is to be added in the database. We will look at the physical and chemical properties of the material. We will look at the technical function of this specific substance, additivation rate, evidence of historic use, polymer specificity, proof of absence. So this is all the type of points that we will check for a new substance to be added. If we see that the substance cannot be excluded because it has been used in plastic, because we see that we cannot exclude it based on all the different points that are listed on the left side, then we will have to do an XRF screening. The XRF screening will check if, based on a specific concentration of specific elements, we can eliminate this substance because it will not be present above the threshold, or if we cannot, and in that case, we still have to analyze it. And the last step will be the chemical analysis that is to be done either with GCMS or LCMS, depending on the substance to be analyzed. And then based on this, we will see whether the substances of concern can be excluded or cannot be excluded. And then we can state with confidence whether the material will be compliant or non-compliant. If I give you a couple of examples related to the assessments related to the properties that were listed. So here we have the chemical and physical properties. So if I give you an example, typically this is related to the boiling point. So you know, in order to process the recyclates, we melt them in an extruder in order to form the recyclates afterwards. It's the same for compounding process. So it means that if we have a specific substance with a very low boiling point, it means that this substance in the end of the process will not be present in a high concentration and therefore above a certain threshold. So this is a kind of example that we can use in order to define whether a substance can be present in the output of the recycled plastic or not. Then if we look at the polymer specificity, so this is also a point, there is specific additives that have been used only in specific polymers. If I give you an example, this is the case for the lead stabilizer for PVC. They have been used only in this type of application, and therefore we do not expect them in other stream. This is why when we enter the typical polymer that we will test, it will already reduce the number of substances to analyze. Now, how does it work with the substance analysis with the XRF screening? So you know the XRF is not meant to analyze the concentration of a molecule, but it's meant to analyze the concentration of a chemical element that is present in the plastic matrix. So this is what we have here as an example so that I can explain you how the system works. You have your specific material in the form of a plaque. You will analyze it via XRF, and then you will get a chemical element concentration. This chemical element concentration is then added in the PRE-1000 tool, and then the PRE-1000 tool is calculating whether then the substance that is related to this chemical element can be present above the threshold or not. How does it work? We have to do a conversion. If I give you an example for this specific brominated flame retardant, that is the DKBDE, it's a brominated flame retardant. So the chemical element that will be the focus here will be the bromine compound. And here what we see is that the molecule, in terms of molecular weight, it will contain 83.3% of bromine by mass. This is calculated based on the molecular weight of the total substance versus the molecular weight of the bromine atom in the substance. And then we will apply this percentage to the threshold that is present in the legislation. So in that case, and at the moment, it's 500 ppm. This will be applied with the 83.3%. And then we obtain a new limit that is the 417 ppm. And this is what we will compare it with when we have the XRF results. So I hope you're still there. This is quite a complex explanation, but the idea is that what to remember is that we really do a conversion in order to compare a chemical element concentration with a chemical element concentration, because if we would compare a chemical element concentration with a substance concentration, we would compare two different things that in the end are not comparable. So then after this XRF testing, then we may have substances that remains. Those substances that remain, then they have to be tested via chemical analysis. So with the literature review, with the XRF testing, each time we eliminate certain substances that cannot be present in the recyclates above a certain threshold, that is the legislation threshold. But they might be remaining chemical substances that in that case we would have to analyze. This can be done either in an internal laboratory of the recycling facility if the recycling facility is equipped, or it can be done externally via an external lab that will perform those analyses. So the recycler will provide the list of potential chemicals that can still be present in the material. And then they will provide this to the laboratory that will then say, do the analysis for those specific targeted substances and say whether those are exceeding the limit or not. This way, there is the possibility to really have the full assessment on the compliance or not of this recycled plastic. So this is the end of the monitoring part of the tool. So these three steps with the literature review, the XRF screening, and then the chemical analysis. The idea of this method is really that it's applied on a long-term monitoring. So it's not a one-shot analysis, but it's rather something that can be done more frequently. So this tool was really designed in order to enable the recycler to assess those substances of concern that might be present in the recyclates in a cost-effective and reliable manner. Then, of course, it's also a very good tool in order to create trust in the recyclates market, but also answering the customer needs, because this is something that is coming more and more often. And of course, it's very important because it is essential to prove that the product legislation is complied with. And if we make the link with the slide at the very beginning on the end of waste status, this is also a very good tool in order to assess and apply for the end of waste status for a recyclates product. This is also increasing the credibility throughout the value chain by enabling a proactive approach to the plastic recycling industry. So gathering a lot of data beforehand, knowing more about the material, the potential contaminants that may be in there is very important to be proactive rather than reactive in that case. So this is it for the explanation of the tool. I hope this is a bit clear and that you understood the purpose of the tool. And now, so I would like to thank you for listening, and I will give back the floor to Carolina.
Thank you, Mathilde. And thank you for explaining the tool. Just as a quick reminder, if you have questions, please write them down on the chat and we will answer them at the end of the session. Okay, so going forward, for the last part, last presentation, we have Ana Rita Neiva. She's a part of the PRIMUS project as well. Ooh. She's a plastic engineering at Coolrec, and she is the leader of the refrigerator to refrigerator pilot. So Anna holds a master's degree in polymer engineering and specializes in tailoring polymeric materials. During her academic research, she developed more sustainable products for food packaging and recycled plastic in automotive applications. With a career developed in the recycled sector, she currently works at plastic engineering as a plastic engineering at Coolrec. carrying out several innovation projects. So, hello, Anarita. Thank you for being here, and the floor is yours.
Hello, Carolina. Thank you. And thank you, everybody, to join this webinar today. So I will start explaining a bit about Coolrec testimony. So to understand a bit on the industrial side, how we have been using this tool and what are advantages of this tool for our quality procedures. So to start, I think it's important to first understand what is Coolrec, what we do here, what are the processes that we have here. We are a recycling company. We treat mainly electrical and electronic waste. So we recycle cooling and refrigerator equipment, small domestic appliances, IT devices, and printed circuit boards, large white goods and heating equipment. And at Coolrec, we do the first treatment, mechanical recycling treatment, where we do the depollution, the dismantling, and also the separation into different fractions, one of them being the plastic fraction. This plastic fraction comes to Coolrec Plastic for further treatment. And as you can see there, we are the producer of high quality recycled plastics, more specialized in polystyrene and ABS from the waste of electrical and electronic equipment. And we are on the top 3 in Europe. We produce over 30,000 tons per year of plastic mix from internal Coolrec sites and also from external suppliers in Europe. And we are the market leader on quality recycled polystyrene from fridge. So this is a little bit about Coolrec and Coolrec Plastics, but for today, I think the most important thing is to understand what are the quality procedures at industrial scale. So as you can imagine, when this plastic mixed plastic fraction reach Coolrec plastic site, it's considered that is an industrial plant. There is a very high variability of heterogeneous waste, solid plastic waste. And for that reason, it's very important that we have a quality control procedure in-house, that we can verify the purity at all the levels of our plant. So from the beginning, when we receive this mixed plastic waste, we have a first input quality control when we need to already meet certain requirements in this step. Then we have metal separation when we remove the metal fraction. And then again, a quality control that we also need to meet some specific requirements, guarantee that the metal fraction is out of this mix. And then we have some air suction when we remove the light contamination. And followed by density technology, we remove heavy fraction, and then electrostatic technology. And at the end, we will have the flakes. And after compounding, we can also have granulates. As you can see, we have the quality control, and we also have the quality assurance. There is a difference between these two, because in the last part on the quality assurance, it's not only purity check, but we also need to meet other quality factors. As Mathilde mentioned at the beginning, the end of waste status is very important for these last steps, because here with the PRE-1000 tool, we can generate and gather data, enough statistical data to prove that the quality of this material ceases to be waste and can be already considered as a product, so has the product status. And for this, of course, we also do a cross-check analysis with the chemical compliance that we perform in external laboratories. And then we can guarantee that actually this tool works as the same way as we are expecting. We also have a quality control plan, not only for an internal analysis, but also to meet certain high markets, so high-end markets. Like, for example, we supply for the toy industry that requires a specific analysis, and that is also part of our quality assurance to some of our products. But then considering that, as I refer, there is a very high heterogeneous nature by this plastic source, you think, how can we guarantee that all these chemical substances are very well identified? So that is one of the challenges that we face in our industry, is that nowadays there are not exactly any procedure standard that consider the batch variability. So there is no exact representativeness of this batch. So they don't consider population factors, number of samples, the sample size, among other factors. So all of this is quite of a challenge if we consider the product lifetime. So considering the sources that we are treating nowadays, if you imagine a refrigerator that was produced 20 years ago and it's now reaching the end of life and reaching a company like Coolrec, we need to consider that the substances that were regulated 20 years ago are not anymore are outdated. So today we need to have a control on these substances, and this means that not only on the processing separation, when you guarantee that by different technologies you can sort out, but also to have the right methodology for the quality control to guarantee that you have a safe product and you have a method to control these possible substances. And there is where the tool can support us, because it's constantly updated through the time. And every time that one substance is added by reach, rose, or pop, as Mathilde mentioned, we know that our product is a safe product. So on this regulatory compliance, as I mentioned, is one of the biggest challenges that we face. What was compliant in 2000, it's not necessarily compliant today, but also the high number of substances that are constantly being added to this regulation. But these are not the only challenges that we face in our industry. Also, the inherent heterogeneity, as I mentioned, we have lack of information is a big gap. And the tool can provide us with the historical use, with the chemical and physical properties, some of the information that it's, let's say, obvious in the material, and also the lack of guidelines for sampling collection. This means that it's very important that when we are collecting the sample, we have to be representative, we need to guarantee that we are collecting as I mentioned, the right sample methodology with the right population, and that the guideline exists for everyone to follow the same process. Then also on the chemical analysis, there is also a lack of guidelines for sampling preparation prior to the chemical analysis on the external laboratory. So as mentioned by Jarkko, during the PRIMUS study, we could identify that sampling preparation before we do the chemical assessment, it's very important, otherwise you will have a big variability of your results. And for that reason, we need to guarantee that you have a very good sample preparation. One of the challenges that we also face is the high analytical costs, external costs. So these will be linked to the third point here mentioned, that is the low frequency of these analysis, because due to the high costs, it's not possible for the industry to perform with high frequency. And when I say high frequency, is for example, to per batch or per big bag, it's not possible to do it because it's not economical viable. So how can we mitigate these factors? With the use of the PRE-1000 method, we can actually mitigate these factors. I have here the example of how we use it. At Coolrec Plastics, we produce, for example, a batch, and you see there by the colors that when you have the sample preparation where you can use the PRE-1000 method, it will explain you what are the points where you should take the sample, how you should take the sample, and then you should use the right methodology also for the sample homogenization. So as we saw by the PRIMUS study, we should do at least extrusion and injection molding to have an homogenized sample. After you have the sample preparation, we can use the XRF tool for statistical data collection. And then with the use of the method, we can have use these exclusion criteria for the substances of concern. So after all these data gathering, we will be able to provide complementary information to the customer on substances of concern. So what is actually the Coolrec testimony about this tool? The key message here today is that the PRE-1000 allows us to use a method to screen, to monitorize the substances of concern in-house with confidence. We can use the XRF tool, which is a practical equipment and simple to handle. We have more than 5 years of data collection, so we performed several evaluations between the results of the method and the results of the external laboratory, and we cross-checked these results to be able to claim with confidence that our materials are safe. And this also allowed us to increase the frequency of the analysis, which also supported the confidence about our materials, and also to verify the compliance with applicable legislation for products such as REACH, POP, and ROSE. As I mentioned also before, with all this data gathering, it was also possible to meet the end of waste criteria that is defined by the Waste Framework Directive. So the authorities trust also the process, because through the extensive quality protocol that we gathered through this monitoring, it was possible to provide a reliable result. And then these in-house methods can be used as it was mentioned before, in an economical and viable way. So with the increase of regulated substances and the constant pressure to sell a material with high substance of concern control, this method is definitely proved that it's possible for recyclers to use something practical and reliable at acceptable cost. So as you saw at the beginning of the presentation by Mathilde, she mentioned that how can the customer request to the supplier approve? So we can do a self-declaration of compliance. This is a draft of a letter with the material reference, like for example, Coolstar Plus, where then you specify what you consider as substances of concern. That is what is included in REACH, in the ROSE, and in the POP regulation. Then we also mentioned that we use the PRE-1000 tool as a method for do an extensively sample and analysis by XRF, and this way we can exclude the possibility of presence of any hazardous substances, considering the elemental composition. So with this we can state with confidence that the materials are or not or have or not containing the supercritical, substance of concern above the regulatory limits. And yeah, this is, I think, a good example and a self-declaration that all the recycling industry can use. Thank you. Now I pass the floor to you, Carolina.
Oh, yes. Thank you, Anarita, and thank you for giving us this testimonial how you are using the tool. So now we have several questions for you three to answer. As a roundtable, the first one will be: what are the necessary steps to create a representative sample of flakes when receiving mixed waste streams? So maybe Matilda and Narita could answer this one.
Yeah, indeed. So the idea is to apply the sampling protocol, like Jarko explained. But of course, it's also how to take the samples. So often we also consider the sampling during the production process, for example, where you can do a continuous sampling out of the funnel of the production process. So you can do a regular one, or you can also take from the different big bags that have been produced. And based on this, you can take different, let's say, sample parts, mix them all together, and then reduce the sample, and then apply the sampling preparation like Jarko proposed.
Jarko, do you want to complement the answer?
Well, I think that's more or less what Mathilde said is
Mm.
what we can do. Yep.
Okay. Okay, for the second question for the roundtable is, what are the key differences between the PRE-1000 tool and other existing standards for plastic recycling, and how do these differences impact the recyclers' ability to compete in a global market?
Maybe I
Matilda?
can
Yeah.
answer. Yeah.
Yeah.
So there are, from my knowledge, limited standards available, not always considering the complex challenges from these sources. So I think it is important to have in mind the constant update of the substances included by the different regulation. And this is something that the tool does, which as coming from the industry, I find it quite important.
Thank you. Thank you, Anarita. Matilda, do you want to complement the answer?
Well, I fully concur with what Anna just said. The idea is indeed that there is no specific standard that is related, especially to plastic recycling for this type of analysis, and especially not for the monitoring part. There might be different standards on, specific method for chemical analysis, but not necessarily applicable to recycled plastic. So this is why this PRE-1000 industry document is quite relevant for the industry, as it can really be this, let's say, monitoring method that can be applicable at the different recycling facilities, and also because it has really been tailor-made for recycled plastics. So this is quite a big advantage in that case.
Yeah, and that it had been made for recyclers and to help them on the whole process. So this is quite important. And this is for Matilda as well. How regularly is this method updated?
Yeah. Indeed, so this is a crucial point because the legislation is being updated very frequently. Therefore, it's important that the method is also updated accordingly. Otherwise, we may have some false results in order to compliance or non-compliance. So we update the method as soon as the SVHCs are public. This is every 6 months. When they're published, then we can update this method. There is also sometimes in between some updates because, so for example, recently we had a substance in the POPs regulation, a brominated flame retardant, the HBCDD, that has been updated, the threshold has been lowered, and therefore this is why we have also updated the tool accordingly to reflect this change in the legislation.
So once you update the tool, the idea is that they should download the tool.
Exactly. So we let the PRE members know that the tool has been updated and that therefore they should use the new version that is available for them.
Okay, perfect. Yeah, this is quite clear and quite important because the regulation is constantly changing. So we had in the chat some questions that I will share my screen right away. Okay. It seems that somebody's sharing. Okay. Well, we need to move forward to the end of the presentation. Sorry for this. Okay. Okay. So here we have the questions. Jarko, you already answered the first question, but I don't know if you want to deeply dive into it. That it was, what was the compounder setup in mechanical recycling? Single screw extruders are often used for pelletizing. Will this be enough to get a good sampling strategy, or do you need to have a compounder with better homogenization, mixing elements as a twin screw extruder?
Yeah. Well, this is also, I already addressed this one in the chat, but these results have been done using a single screw extruder and indicating that it is a sufficient tool to do the homogenization. And we have also discussed quite a lot in the within the Primus community about whether there is a need for the twin screw extruder. Certainly the homogenization is more effective in that one, but then based on the results that we have so far, it seems that single screw extruder is sufficient, and we can proceed with that one.
Thank you, Jericho, for explaining a little bit more the answer that you already wrote down on the chat. For Matilde, where can we find the pre-tool? And it is free?
So the PRE-1000 tool is free for recyclers. So any plastic recyclers can contact PRE, and PRE will give access to the tool. However, for companies that are not plastic recyclers but want access to the tool, then they have to become PRE members in order to get access to the tool.
Okay, so if you are a recycler, you can contact Matilde directly, right?
Correct.
That's good. And then you mentioned that it's a cost-effective method. What is the range of cost of XRF capable to make the presented analysis?
Indeed. So this is something I have not mentioned. The XRF we're talking here is the handheld XRF. So this is like shaped as a kind of a gun that is pointed towards the plastic material as a plaque and then tested. This is very fast. The analysis can be 20 seconds, 30 seconds, and then you get the results. In terms of cost, usually it's roughly like 10K to buy the handheld gun, and then you have 10K for the training because you need a specific radiation training in order to have this device in the facility. But what has to keep in mind is that most of the recyclers are already equipped with such a tool. This is why we have taken this tool as a basis for the method, because it's present in quite a lot of recycling facilities. And the idea was not for the recycler to purchase another tool or to need a specific, very complex training for chemical analysis. This is quite, let's say, intuitive to use, quite straightforward in terms of analysis of results. So this is why we decided to go for this tool in terms of analysis.
Thank you, Matilde. Thank you for your answer. Then for Anna Rita, and this first question could be answered for by Matilde as well, but is the list of 200 substances of concern are all including elements that are detectable by the XRF test?
So that is a very good question. Not all are included by the XRF. That is one of the limitations, of course, of this device. But this is also very important to make it clear. This tool is also doesn't work to provide you a certification or a guarantee that any possible substances are at all present. You need to always do the extra analysis with a certified laboratory, if possible, also accredited laboratory. And then, of course, you cross-check the possible substances that this equipment allows you to. But it's not a method that will that you will be able to monitor all substances, because you also have the limitation of this equipment. I don't know if Mathilde wants to add something.
Yeah. Thank you, Anna. It's clear. The only thing I would like to add is an example. So, for example, you have certain substances like the phthalates, where you will have no specific chemical elements that will give chemical element concentration via the XRF. It means that for those ones, they will always pop up in the tool as substances to analyze chemically. So because you have, this reduction of substances with the different steps, so the literature review, of course, phthalate cannot be excluded because they have been used in plastic in the past. Then a second point is the XRF. With the XRF testing, you cannot eliminate the phthalates. So therefore, they will pop up in the chemical analysis. And then it's up to the recycler to really do this analysis to check if those phthalates are not above the threshold listed in the chemical legislation. So this is indeed one example where the XRF will not be able to eliminate the substance.
Thank you. Thank you both. This is quite important as well. And for Anarita, what is the batch size of Coolrec plastic? Is every big bag checked by the methodology of XRF?
So not necessarily. This is also up to the recycler. What we do, it's as we already have a quite extensive quality control, we start reducing depending on the grades that we had more trust. So for some materials we performed per batch, some materials we performed per 5 in 5 batch, but we don't have any material that we perform per big bag because the sample preparation, it takes quite some time. It's if you want to have some reliable result, you need to do a very careful sampling preparation. So for that reason, we don't perform per big bag. But it's also possible, and the tool can be used if you are not confident about your material, you can use the tool for per each big bag.
Thank you, Anarita. Hopefully, all the questions are answered. If you have any further question, please write them down, and then we will add them to the answers to the presentation. So we reached the end of our webinar. Thank you, Anarita, Matilda, and Jarko for being the experts in this session and presenting the tool PRE-1000. And if you want to learn more about our project, please join our community and follow us. And then we will be sharing this webinar on our YouTube channel, on our webpage, and different social medias. And we will share the presentation as well with you. Thank you all.
Thank you.
Thank you.